Okay, this is the mini lecture. It goes with your geometry packet 11.1.1 to 11.1.5. I already did a video a while back on doing the first problem. I wanted to talk about problem number 5. So in your packet, I don't think in class we went over how to get the surface area of a cone. Okay, so the surface area of a cone, you can probably tell if you took it apart. You could just get the surface area of the bottom would be pi r squared. And then this thing, this lateral surface area, well, there's a formula for it, but you probably don't know where this came from. It says that it's pi r l, and we've never talked about this, so that's what this video is going to be about. And we're going to do problem number 5 in a minute. L is actually we use the small letter L to stand for the slant height. So if you look at this this cone, this height, the perpendicular height from the center of the base that goes all the way up to the apex, is called h for height, right? And you use that when you do volume, because we know that volume is 1/3 times base area times height. This height is what you would use for volume, okay? But this L, this slant height, it's a different height. That's what you need to use for surface area. Okay, so for surface area, you would take the bottom, which is pi r squared, and we've already talked about that. And then this thing, think of this as like a rolled up, cone-shaped piece of paper, or think of it as one of those little party hats that you can wear. And think of, if you cut it, if you just took your scissors and cut it, you could spread it out on the table and it might be shaped kind of like this. And then you could find the area. This is just a part of a circle, right? So you'll notice that L is the radius of this circle. Okay, and I just drew in, it wouldn't be in a whole circle, right? It would if you rolled it back up and turned it back into a party hat, it would, this side and this side would meet each other, and it would, be cone-shaped, right? Okay, so how do we get the surface area? We know how to do this, is just pi r squared. How do we get this surface area? Well, they tell us in our packet and in our math notes box, they tell us it's just pi r l, but why is it pi r l? So you can kind of derive this formula just by asking yourself, well, what would the area be if it was a whole circle? It would be pi l squared, right? The radius is l, pi l squared, right? And then you would times it by whatever fraction of a circle it is. Okay, so the distance from this point down to this point, when you roll this thing up and make your party hat out of it, it fits exactly on this base. So we know that the distance from here around to here is the same as the circumference of this base. Well, the circumference of the base, is 2 pi r, right? Because that's our formula that we learned for circumference. So 2 pi r is this distance out of a total possible, all the way around the circle would be, well, 2 pi r of this bigger circle, r is l, so that's why it's 2 pi l. And then you'll see that there's other videos on YouTube where they actually pull a cylinder apart. That they actually cut it and show it to you, that probably make more sense than this one, that you can watch if you're interested in where this comes from. Some of you guys are just going to say, oh, there's the formula, and you're just going to plug the numbers in, but you can see that if I do fraction math, I'll end up with pi times l times r, or pi r l. So it turns out that surface area, there's your formula, okay? So now you have a formula for volume. You have a formula for surface area, and so now it's just a matter of plugging the numbers in. So we'll go do number 5 and plug the numbers in. Okay, so number 5 says, it has a picture. It says, what's the total surface area and volume of the cone at right? So surface area Give me another piece of paper here. Well, we just said that we think surface area is pi r squared plus pi rl. Okay, so we just plug the numbers in. Okay, so do we know what r is? Yes, it's 5. We don't know what L is. Okay, so I'm going to guess some of you guys can use your imagination here and find out L by look at this triangle right here. Pythagorean theorem, right? So you're going to go, because we got a right triangle right here. So you're going to go 5 squared plus 12 squared equals c squared. 5 squared is 25. 144, that's c squared. Let's see. I bet that's going to be 13, isn't it? I'm just checking to make sure. Okay, so that's 169. I know that the square root of 169 is 13. And I should have recognized that sooner because it's a Pythagorean triple. Well, we can't see because the sun. L is 13. We used Pythagorean theorem to find it. I'll write a little 13. Okay. And then we can just, you have the answers in your book, so you can check if they wanted to, what's 5 times 13? 5 times 13. That's 65. You can check and see if they want to leave it as pi or not. So what's 25 plus 65? I don't know. Let's see. That's 25. 90. And then it's a surface area, so it's going to be square feet. And then we can look in here and see, you know, there's some answers, right? So they left it as 90 pi, and then they also put it in their calculator and got the decimal. I'm totally fine with you leaving it as 90 pi. I'm going to leave mine as 90 pi, because I think it's nicer that way. That's surface area. Okay, volume. We already know a formula for volume. I have mine memorized. It's 1/3 times base area. Remember, because we learned this for pyramids, and a circle is just a round pyramid. Okay, but so the base area, like we said, is a circle. So the area of a circle is pi r squared. And what's the height? Well, I think we have a picture of it, and it shows us the height. The height is, I think it was 12. The height's 12. The 3 and the 12 can cancel out, and now they equal 4. Oh, so what's R? R was 5. R is 5. So 5 squared. 5 squared. So that's 25 times 4. Because 5 squared is 25 times 4. 25 times 4, that's 100 pi. They were feet. Cubic feet. And then I can look in my answer key and make sure that I didn't make any mistakes. Okay, so that's the same as 100 pi, because if you put here, how do I find pi on this thing? Pi times 100. See how it's the same thing? They rounded it. Okay, so I don't care which way you leave it. And that's it.